Hi everyone. In this video, we will build an multi-agent system, using Claude Code. Okay. So the use case, what I have selected is a very simple one. So to understand, so basically we have this NGS QC pipeline, right? So where you take the first QC file and then the first step is like you do a quality check using FastQC. Then let's say if you have multiple samples, then you can run a multi-QC analysis to aggregate the results. And based on that, you just do the interpretation. You as a human, you will understand, you will go through the report, then come up with the analysis, and finally you say which samples passed and which samples failed. So this is a basic QC pipeline. So now think that currently, if no agent is there, as a human you will run first QC yourself, then you will aggregate, run the multi QC, and then finally you will look into the report and get the interpretation of it, right? So this is what we are changing. We are thinking how we can leverage it using an agent, right? So when we do this thing, like, okay, so now we can do three different ways we can build. First is like the single agent approach. That means one single agent doing all the three steps, everything. Then there is second approach is like each part dedicate it to a specialized sub agents. We would say, let's say first QC analysis, you delegate it to an expert who is expert in first QC, same an expert for the aggregation, and same interpretation expert or an agent, you can say. And the third approach what we will see is like how you can empower each of the sub agents. Let's say if you go with multi-agent pipeline, how we can further empower using the skills. Okay, so that we will see in this video. So we'll talk the pros and cons of single agent versus multi-agent kind of thing. So the first one is like this is a very straightforward, and this is more of kind of chatting. You tell the agent, hey, please run this pipeline. So the main agent in this case, let's say it will run first QC on every first Q file, then it will run the multi QC itself to aggregate the report, then it will fetch some metrics, then it will think and it will say pass or fail, and finally it will give the report to the final verdict to the user. So the good advantage of this approach is like you don't have to worry about handoffs between sub agents, three agents. So single agent will do everything, but the limitation is that like the context window, right? Because every steps it will generate some input, some outputs. So that means your each iteration your context window is getting increased. So for a small pipeline it is fine, but when the pipeline becomes big, a single agent cannot think. This is happens with us, right? When we think a lot of things, we cannot process properly, cannot see the minor details. Like sometimes we do mistakes, so chances of mistakes is high, right? So that's what you do a second approach, where there will be a main orchestrator which you can delegate the task into three different sub agents. So for example, here let's call the QC runner. It will run the first QC per sample. So this will run per sample first QC. But this is the good thing, like if there are 10 samples are there, 10 such runners will run parallelly. So that's the scalability kind of thing with when you go with the sub agent kind of thing. And here the second step is like the aggregator, and then third is the interpreter. So the communication doesn't go between agent to agent. So always the child will connect, talk to the parent. So that means orchestrator will think, okay, now it's time to run it. So it will send the task, delegate the task to runner, and then whatever the results we get, then based on that it will send to aggregator and get back the results, and then it will go to the interpreter. So that's how the orchestrator will do everything, but agents will do its own part. So the advantage is like like each sub agent runs in its own isolated context window. For example, whenever first QC steps is running by this agent, let's say this consumes around 10,000 token. So all this is part of this. So all those information doesn't go there, right? So that way this one will only see the message what this agent will send to that. So that way the context window of this one is isolated from this one. Same for others, right? So that's how it works. So the advantage and disadvantage is like single agent means it's very simple to build and you don't have to worry about the design properly, and no hand off latency means if this agent takes a lot of time, this keeps on waiting, those kind of thing, and during handoff, some if it is not properly done, then the communication gap will be there. Okay, and whatever, because this main agent will not see what is happening in this agent, right? It only sees the final response from that agent. So he cannot go and check inside what is how this aggregator worked, that's the thing. And so no head of latency and full reasoning trail in one context. So that means in the single context only you have all the information you have. Okay, so the cons is like no true parallelism, and noisy tool outputs pollutes the judgment. For example, let's say this is a bad, noisy, so that means it will keep trying, and then that main context window will get polluted, right? But in case of sub-agent mode, if something happens, so this context only will get polluted, not the primary one. And so as the tool grows, the model will be not perform well, performance will degrade. So but the sub agent, the process like isolated clean context per agent or per stage, so you see a real parallelism across samples as well, and scope tool permission per row. And another advantage is like with this approach, like tomorrow if you want to introduce another, let's say FastP or any module, you can simply plug in and tell the orchestrator and change the pipeline. So that way, yeah. And so the cons is like more moving parts, right? Because so many things are happening, and orchestrator only sees the summaries. Sometimes it's for a short. This is not a good example, I would say, because this is very simple example what I'm showing you. But in a real complex, you're doing a multi omics pipeline where you have genomics, transcriptomics, proteomics, and aggregate. There this kind of multi-agent system will help, right? So you have to for a linear, very simple pipeline, you can go with this single simple agent as well. Okay, so that's what rule of thumb, like if your stages are strictly linear with no disagreement to resolve, then a single agent is enough. Okay, but multi-agent earns its complexity with parallel work, and let's say conflicting expert opinion, or maybe some noisy tool output, those kind of cases, we can go with this multiple sub agents case. Okay, so now, so that's what we will be doing in this I'll just show you because this one is very straightforward, because you just tell Cloud Code ki, hey, run this one, it will run for you. But now we will mainly focus on this system. Like I'll show you how we can build this aggregation kind of thing. Okay, and so now before doing that, we will be using Claude Code, not Cloud API. So there is a certain difference that I wanted to tell you. Cloud Code is more of a paid programmer. Okay, you buy a monthly subscription, so you pay, let's say, I think $20 something you pay one time, and you can say that unlimited work you can do. There is no pay per usage basis. The Cloud Code will sit in a project, he will try to understand all the project, and you will you can do a lot of things. So this is what I would recommend to do. And Cloud API is more of when you are building some product, building some software, and so that you are sending some request to the cloud Anthropic API, getting some response. So this is more of software building kind of thing. So just let me show you here what is the Cloud API. So Cloud Code is an agentic command line tool. Okay, and it is designed for software developer to edit local files, run tests directly in the terminal. Means it's like kind of pair programmer, that way you can think. So someone is there, you ask something, he will do the code for you, and you can do the results. Sorry for that. But Cloud API is a programmatic endpoint. Okay, so in my earlier videos you might have seen, like like we have how you can connect to OpenAI API. The same way we have Anthropic API, and so you want to wire the cloud's intelligence into your let's say custom application. You are building some software like that. And if you go to this platform, right, you can see the pricing here. So in the free plan, it's just for chatting kind of thing, chat GPT kind of thing. It doesn't include Cloud Code, but Cloud Code is included in the monthly subscription. So it includes the Cloud Code. So you pay just $17, around that comes around 2,000 rupees something. So if you pay that much, you can do a lot of work itself. But now Cloud Code API, this is what token based. It's, for example, if I'm using Sonnet 5 model and I will be using per million token, $2 I will consume, and output is that for output 1 million token output I will consume 10. That's why this is very expensive. Only in the software, in that case, people use it in enterprise level. Okay, so yeah, so with that we will be using the Cloud Code, and I will show you how it works. Okay, so when you open this one, right, sorry for that. Yeah, so this is what we will be doing. So first what we will do is this workflow, like build the sub agents. So next what we will do is like, same concept, but here we will use something called skills. Already I have talked some previous videos like how you can use skills, the same, but now we will empower our agents with the skill. This is the second, so two version I will show. Let's start with the first one. Okay, so we will creating three agents and one main agent. Okay, so I have already created v1 system, so I will show you. So I will just copy this to here in my demo folder, and so I'll rename it. This is my plot.md. This is my .plot folder. Okay, so let me open my workspace. Okay, so now this is the main orchestrator. So this is just a simple markdown file, and so just let me preview it so that you can read it here. Or now I'll just close this. So you can see that this is what so the instruction, the cloud.md file is the main system prompt, you would say. This is what we can delegate it to the Claude Code. So we are saying that, hey, this is the NGS QC pipeline, and you do not. So here I've explicitly stated that you are the orchestrator. You do not run FastQC MultiQC interpretation yourself. You delegate each stage to a specialized sub-agent and pass the results between them. So now the pipeline stage is like run sample QC. So I'm saying delegate to QC runner. So when you come to QC runner, so how the sub-agents you create a .cloud folder, and within that create a folder agents, and then you can I have just three markdown files. So these are individual agents. Okay, for the runner agent and the interpreter and aggregator. So basically simple instruction, you would say, or markdown file, and the format is like you have to give triple dot and a triple hyphen, and here you give the name of the agent. So here the QC runner agent, what it does and what permission it has. So for example, because for running the FastQC we need to provide some tool, right? We need to provide permission for read, write, and globe, is like regular search pattern, also the bash tool where it can run it, and what kind of model I'm using. Sonnet model. There are other models are there, like Opus and those kind of. So what LLM model you are using. So this is what the this is what the agent sees. This is the agent instruction. This is how you write an agent, and below I have given some instruction, like how you have to do it, like list all the FastQ file and run it, and what kind of output format. So let me open this in preview mode. Probably you will see that. So here the instruction is like, hey, this is the name, this is the description, this is the tools, this is the model, and this is the task. Like, hey, given a directory FastQ file, usually in the data and raw FastQ folder, you list out the files and then you run like this, and after verify, you'll get some output, and output format not a full log dump. You just give me the output like this. Okay, and the boundaries is like some rules we have restricted, like, hey, do not open or read the content of FastQC report to judge quality. That is the QC interpreter's job. So because I just wanted to show you, like, otherwise this agent is so smart that it will do everything on its own. So because I'm just demoing, like, so FastQC's role is only to run FastQC, not interpret. Okay, similarly, do not run MultiQC. That is the QC aggregator's job. So this instruction will restrict that runner to only run. Okay, so keep your written summary short. The orchestrator does not need the raw FastQC console output. Just pass file per sample. So this kind of instruction is the runner agent. So now if you go to the second stage, aggregator stage, so it will now the MultiQC step. So here if you see it, right, so what the instruction is like. So here the name is this one. So this runs the MultiQC to aggregate per sample FastQC report. Use only after all the individual FastQC reports exist in the output FastQC folder, and do not use this agent to run FastQC itself or to judge whether metrics pass or fail. So I've explicitly stated that your role is to just only do the MultiQC analysis. Okay, same how it will run MultiQC and how we expect it to do the output. Okay, so now in this case, your example says MultiQC will generate the output in JSON format, but here if you see that I have asked it to just give me an output in this format, but I did not give any script, nothing for now, where the agent will write the Python script itself to fetch the data from the JSON file, and it will give me the response like that. Okay, and I have given that output format. How it will return this output format to the primary agent is like, return only a short confirmation, not the raw JSON content. Just say that, hey, aggregated X samples into these files. For flags present in this run is what kind of flags are present. This is how the output, we are expecting the output from the aggregator agent. Okay, so now the rules. Hey, do not decide whether a sample pass or fail. That is the job of the interpreter. Third job. Okay, and again, do not rerun FastQC. Even if a report looks incomplete, report the issues instead. Like that, I have given the instruction here. Okay, and the third is the interpreter. So here I will just show you what it. Again, use the name, the description, and so use only after the aggregator has produced the output JSON file. This agent does not execute the QC itself. So now this interpreter do not read any tools for editing, because this has to interpret the result. So that's why I have restricted the tools only to read and write. Okay, and but here if you see, for runner we need bash, read, write, globe, and you can see for aggregator we we do not need globe. Because we do not need to search for FastQC, because we have given that output is there in this folder, it will find it that path. Okay, so we do not need to provide the globe pattern. So that's how we are restricting the agent to with respect to the tools itself. Now for the interpreter, we just need read and write. It will read the report and it will give me the summary. So here we are just showing like, how it will read. Your task is go to this folder and for each samples, do this kind of analysis, and finally give me an output in this, QC report JSON format. Again, then return a short plain language summary to the orchestrator. For example, hey, 3 of the 4 sample pass, this is how it was done. So then again, the boundaries like do not modify any tool, do not fix, like that. So you see the reason I'm just telling is like how you can write this kind of instruction. So basically the agents are nothing but you create this Claude.md file. Okay, this is the primary orchestrator. Oh, I did not say about this, right? So now we talked about all these sub agents. So let's see how the main agent instruction. Okay, so here the main agent, like pipeline stage, you run this one, delegate to QC runner, then delegate to aggregator, delegate to the QC interpreter. Okay, so only after stage 1 is complete, only after stage 2 complete, do this one. Okay, so then finally you report back to the results after all this summary you give like this. And rules, like very important, this is the main orchestrator rules, very important. Just see, so I have written that, never skip a stage or run a later stage tool yourself as a shortcut. Generally what these rules are, these are very smart, right? So they say that, hey, aggregator didn't do, I will do it, but just for demo purpose we are so because this is very non-regulated, right? Because otherwise they will do anything. So with the prompt only you can check, provide a check. So then I have stated that if a sub agent reports a failure, for example, in this demo you will see that I have not installed MultiQC myself, okay, and that not available, so it will fail. So I've said that stop and surface that to the user rather than proceeding to the next stage with incomplete data. Don't install yourself, so just say that it is failed. Okay, and treat threshold as a judgment call for the QC interpreter, not hard-coded pass fail rule by apply. So don't use your brain to give me the output, because interpreter is the main expert. Okay, whatever that interpreter gives, you pass me that. Otherwise this main orchestrator will use its own knowledge to report it back. That's what we don't want. So you can see that with this instruction, dedicated instruction, we are giving the dedicated role. Hey, how the aggregator, what is the boundary for it, how the boundary for the runner, what is the boundary for the aggregator, what is the boundary for the main orchestrator that we have given. Okay, so with that, so you see the folder structure, very simple. You see the Claude.md, this is the main orchestrator, and then within that you create a .cloud folder in the project, and agents QC aggregate interpretation run. Okay, so now you open the Claude Code. So usually there are 2 flavors you will see in the Claude Code. One is the this is the VS Code. I have opened it. It will look like this, more ChatGPT kind. This is what I like. Or alternately you can also do terminal mode. Some people like in the terminal mode, where you can write open Claude in terminal. So this will just look more like this. Okay, okay, like that. You can do this Claude, which I don't like it. Okay, so now I will just see. So now we don't have the data, right? I will just copy. Sorry for that. Okay, I need to copy the data, right? Okay, so I will just copy the main FastQ folder, which I have all the data. So two FastQ files I have. I will just copy this data into my demo folder. Okay, cool. So I have my data with me. So now I will just refresh this one. You'll see that the FastQ is there. So we'll simply ask the Claude Code, hey, run QC analysis for in this project. Okay, so now in the Claude Code, when you do it, you have different modes, right? Manual mode means every time it will ask you. Edit automatically means if you want it wants to edit some file, you are giving that, edit automatically. And auto mode is the most flexible mode. We are giving 100% permission that hey, do everything. But the auto mode works in a different way. So it's not like full permission, because behind the scene, whatever the action it takes, there is a from Anthropic side or cloud side, there is an checker kind of thing is that it will check, like every action it is checking, it has to pass through that, then only it will do. So auto is, still there is safety check is there. Okay, that's what, Cloud will approve actions that pass a safety check and pause for anything risky, like something very risky, it will pause into last queue. But here, so currently, because I'll just show you with the manual mode, then in the second round I will go with the auto mode to just show you. Okay, so let's stream. So now let's run it. Okay, so now just to before that, I wanted to show you, like, I have okay, so let's exit this one. So in my right, I have FastQC installed. Okay, now so that means my runner will pass, but I don't have MultiQC installed right now. Okay, so that's why it should fail in this stage. So let's see how this aggregator will behave. Okay, so hey, run QC analysis in this project. Please bear with me, because this is, I want to show you how it works. I will just read through so how it is working. So now it is looking into the project structure. So it has started it. So now it is reading these, three agents. So now you see that it says that delegating stage 1 to two parallel QC runner invocation, because two samples, right? So it will now run two agents. So that's the beauty of, agent. So now you see agent first QC on this sample and this one. So now this now gave the response is like that. So it is doing that. So now next it comes to so it's now checking the sample fast files whether, so it is completed, right? So now it is checking whether file exists or not. I say yes, allow it, because it's a manual mode, I have to give permission every time it is asking. So now this will is run fast QC on a assigned sample. Okay, this is what that step, I'm just allowing it. Again, rust fast QC on the second sample, so I'm allowing now the first QC. So this is all going with the first agent. Okay, it is running behind the scene, but the main orchestrator will not able to see what is happening that. So that's what the context window is isolated. The main orchestrator doesn't see everything. This is the part of this agent. You see from here, this is the main agent is red color, and this is all of the green one is the the second agent. Okay, so now it is done. And now this, it comes to the gray, right? So that means again the main agent comes. So now the stage 1 is complete for the both samples, now delegating to the stage 2. So now this, it is passing to the multi-QC aggregation. So now this message, it has passed to the second agent. Hey, you are acting as a QC aggregator sub agent defined in this, and you are now, this is from here to here. What is we have written, everything is the message the main orchestrator passes to the second agent. Okay, and it also provides some additional information that he may need to run it, right? So that's how it is doing. And so now it is checking, it is already delegated. So now you see the color change, that means now this goes to the aggregator agent. So it has already started it, and it is now, it is asking me permission check if MultiQC is installed. So in this case, now MultiQC is not installed, it will fail, because see, you got a output the MultiQC command not found. It will try its brain, it will say that search for MultiQC in alternate location, it will try here and there. So MultiQC is not installed, and usually, if you don't give some restriction, it will try to install and do the sub-agents. So again, no modules, it did not find it. Okay, so let it search. Okay, it didn't find. So now you see it reverted back to the main agent orchestrator. So now stopping the pipeline as per the project rule that stage 2 failed, so I did not run the stage 3. That's how the orchestrator we have given the instruction. So the stage 1 complete, stage 2 is blocked, stage 3 interpretation not run. So to unblock, so now it says that install MultiQC, changes in environment, then it should work. So what I will do now, I will install it, right? So first I will create a virtual environment. Okay, and yeah, so it will take some time. I'll just pause my video and then we can continue. So my VNB is created. So now I will activate source VNB bin, and you say simply activate. Now I have UV installed, so I say UV pip install MultiQC. Okay, if you don't have UV installed, simply you can say pip install MultiQC. UV is much faster than pip, so I'll just okay, MultiQC is installed. So just to show you MultiQC -h, it should give me. So now I can simply continue here because I'll say that a MultiQC is installed in .venv virtual environment. Please proceed. Because this is a temporary halt, right? So, but when we do the second iteration, I'll show you because VNB will be installed. Okay, it is there, it is installed. So we'll not pause it here. So let it run. So I'm just still in the same context window. I'm chatting with the orchestrator here. So now the orchestrator will now say locate MultiQC in the VNB. So just I have given the permission to it. So again, it's a gray color. That means that it's the main orchestrator I'm talking now. Sorry, I got some cold. So let it run. So now it found it. It is there, and so now it is now resuming from the rerunning the stage 2. Okay, so now again it now spawned the second agent, so it will do the aggregation. So again the color change. So now this one, you see it has listed it list project directory and all, and now it is asking me run FastQC on the FastQC output. It will now run the FastQC. So yeah, it has run it. So now it will now write the Python script to process the output. Okay, it completed it. Usually you can also write some script to do it. Say that after processing you can run the script to do it. So now it is now dumping the raw FastQC data section, and it's it tries to process like this. All the output it is trying to fetching it here, and then it is writing a Python script to give the output, because in the instruction we have said that, hey, give me the output in this format. Uh, sorry, aggregator, right? My bad. So I said that we need an output in this format, like at least duplicate GC adapter per total sequence. This format we give. So that's what it's trying to do. It try to give me the output in this format, right? This is all is happening behind the second agent itself. Okay. So now stage 2 done. Now it is now delegating to the stage 3. So now it says that agent is interpretation QC matrix, and this is the instruction it passed. Hey, you are acting as a QC interpreter sub agent defined in this project. Your definition is what we have given, the same from here to here. Apart from that, it gives some extra information, so it passes, and based on that it now it's summary, it is reading this QC summary JSON file, which is the output from the aggregator, and then it is doing all this analysis. It will trying to read some plots, so many things it will do, because that's the interpretation job. So now it is asking me whether to write in the QC reports JSON file or not. So now this is the final output we have asked to write. So this is the final verdict it will give. Okay, so I'll just show you, let it run. So now this interpretation is finished, so it will now revert back to the answer. This is how the summary it is sending back. So it is finished. So now this, the main agent will now so it says completed, right? So it says that all of this passed for, etc, etc, and one thing to confirm outside QC, it is just leave it, but only thing, like, it has done the analysis, and we will see all the output over here. So if I just refresh, we have the output folder, FastQC, then MultiQC, and we have the QC report JSON file. This is the final output. So I'll just show you the word wrap. Okay, so this is the final verdict. It says, this is how it is, and the second sample, what the final verdict is. So now you see, in short, what we did, like, we created a very multi-agent system. The main agent was this cloud.md file. So this is what the main instruction, and then we have created a folder .claude, and within that we have agents folder, and we just keep 3 agent system. So we completed this one. So we created this. So the folder structure was this, right? So Claude.md is the main orchestrator, .cloud, agent, and we had these 3 agent. But now, so in this 3 agent, we had given some instruction. But now, whatever, now we will do little bit advanced, where we will now introduce skills. So skills is, very, very dedicated, again, some set of instruction that you can say, link with this agent. For example, QC runner, the fast QC, right? So we are saying that, what are the best practices that this agent should follow. So that's what this, we are giving some skill document. So now this agent will use that skill to do it. Similarly, aggregator will use the aggregation skills to do it, and interpreter will use the interpreter skills to do it. So skills is a is more empowerment. The advantage of skill is like, I'll show you like why we need skill document, why we don't need it skill document, because so let's do that. Okay, so then I will tell like why we need skill document. Okay, so I will just do one thing. I'll just clear this .claude and output these 2 folder and Claude. So this is from the first this one, and output, it's not there. Perfect. So now I will just copy the second version of the code, v2 system, which is the Claude, and this one I'm just copying. Okay, then I'll show you what is this. Okay, so now I come back again here. So I just refresh it. So now we will start a fresh session. Okay. Okay, so now if you see the same structure, so here the Claude.md, here we are saying that same thing, run per QC sample, and then aggregate, and then interpret the results, and how you will report the results. Rules like never skip a step. If it fails, then simply stop and don't do your task like that. So, but there is a change now. So if I go to runner agent, so now you will see that something else is added here. So here the name remains same, the description is this one, and the tools what we given the model, but this is the only thing we have added. And what's the skills document. So here what they are saying that this agent is now equipped with a particular skill, something called FastQC execution. So now this skill should be present in the same folder .claude, and within skills you can keep any folder. The folder, the skill name should match with the folder name, like here the FastQC execution. So the folder name, and within that we have simply called skills.md file. Okay, so this file you see, right? This file is the skill document. Okay, so if you see, let me open it here. So here I have this the FastQC skill document. So this tool skills document is like how to interpret correctly FastQC on the FastQ file, the command, how it will execute, and how the output will be generated, and how the verify success, how the common failure modes, like that. So as you see, this is very, very detailed information, but still it is not that great, but still some information is there. Okay, now the same, it goes to my second skill, where I have talked about aggregator. The name is MultiQC aggregation, and its skill document is, see, this is how you will close this one and open into a preview mode. So hey, this is the MultiQC. The name is the skill is the aggregation, what it does, and MultiQC aggregation, the command, how it will run, where the useful data lands, and how it will extract it, and common pitfall. So this is what the guideline for the running the MultiQC. So the same goes for the third skill, like how it will aggregate. So we have two skill. One more thing is like, yeah. So if you go to the interpretation, right? So here the interpretation skill is how it will interpret the result. So core principle, the pass verdict, pass with trimming, flag, decision process, how the writing region. Furthermore, if you see, right, it says that you also need some reference for full metrics guide. You know you can refer this skill threshold guidance, like how it will decide, like good or bad. So for example, duplicate rate, if it is greater than 20%, then 50% is what DC content, how it will interpret. Adapter content, it is how it will rate. All entire detail is there in the not this file, it's there in the second file. So this one is referring that. So now there is two projects. So what one thing I could have done here is like all these nodes, right, whatever it is there for to execute FastQC, I could have copied here and put it in the like this runner itself only, right? But the difference is like, if I put all this information, okay, so this is the QC run agent instruction. Now this is the skill from the first QC. If I put everything over here, so now this size, context size will increase, the token usage will increase. But how skill works, right? Skill only when it goes to skill document, right? It only loads this much in the context, because the agent needs to know what skill it has. It doesn't need to know, what it is. So when actually it wants to use that skill, then only it will keep on reading. Okay, so that's the advantage of using skill document. So that's why you should separate skill from the agent instruction. So this agent, you should specify what this agent is will do. So it's more of instruction to the agent, like a role kind of thing you can write, but the skill set we will use it like this. Okay, so now all is good. So let's see this here. Okay, so we will now start with hey, run QC analysis in this project. That's all. And this time I will go with the auto mode. Okay, so that I'm giving, because I know everything will work, and I will just give auto mode. So let's see how it is, how it will do. Okay, so I'll start looking at the project. So let me expand it. Okay, so now it has started looking into the project. So now it's saying two samples found, running the stage one via the QC runner. Okay, but now if I see here, right, so okay, consult the, so here the agent is now orchestrated, is giving the instruction that consult this particular skills, FastQ execution skills. So if you see, right, these skills you execute to do this one. So that's how the instruction is given. So and it has now spanned this agent. So first QC on this sample, the second agent on this sample. Now it is running, the both of them ran, and it is happening. I don't have to allow the permission because I have given it the auto mode, and it is all generated, it is doing everything. So now it is delegating the QC aggregator. Okay, so now before that, just I wanted to show you skills, right, whether it is using, okay, already have same thing will come. Okay, means I wanted to confirm whether skill is there or not. So now it's spawning the agent. So this is how the instruction it got. Hey, consult the MultiQC aggregation skills to do it, right? So that's how now this agent will use the skills, particularly what is it is given, and it will run the MultiQC analysis. So it will try to aggregate the results. So now it will write some Python script to fetch those information the way we want, like total sequence, GC content, average, like that. Automatically it will do. Now it has done aggregation complete. Now it is moving to the interpretation via the QC interpretation skills. Okay, so now again, if I say that so it gives the instruction. I'm just checking where it is written. So now you see it read this one, and also it read the particular skills. Okay, threshold guidance, because it is there in the skill, right? Skill, if you go to interpretation, it is using this threshold guidance skills. It read it, and based on that it tried to read all the content. It will read it, and finally it will give the interpretation. Yeah, so it completed the analysis. Finally it gives like QC results, etc, etc, and the final is like final verdict and reasoning is over here, right? So again the same verdict you see. Okay, it gives some reasoning like GC content is this much based on this pass fail something something. Okay, so now in short, you see like how we started with to do this pipeline, right? We created 3 agents. The first version what we saw is like simply the agent creation. In the second stage, we empowered each of these agent with the dedicated skills, right? So, and the folder structure is like .claude with agents and skills. Within that, you just simply mark down file, and skills you also again mark down file. So agents goes to agents folder, skills goes to skills folder. Very simple. And then simply you chat, then everything will be done. Okay, so this was one example. Alternately, some advanced example where the real use would be like, for example, if you are working with single cell pipeline. So for example, let's say once you have got the markers, right? So you want to annotate it, right? So there are different approaches are there, like some tools are marker based annotation approach, some reference based, some LLM based. So I have a dedicated series created for this. Just an example, like so because each of these are very specialized, so you can have multiple agents dedicated for this kind of run, and then you can have one orchestrator, or let's say an arbiter agent, who will gather the output from all these and finally come up with some assessment, like let's say all 3 agree, or let's say 2 agree, 1 disagree, or all 3 disagree. Those kind of thing you can build a system. And some other approaches what you can use, like variant calling interpretation, like n number. So whatever pipeline is that you can feed it into where different domain knowledge is required, so you can equip with skills, and you can do this kind of analysis as well. So yeah, so the key takeaways is like start very simple. So start with a single agent. You can go with, if pipeline is very linear, and reach for sub-agents when you need context isolation. That means you don't want to pollute the main context, and parallelism you want, and skills is better, how you can that agent can do more better way, best guidelines, those kind of things, you do it. Okay, so with that I think we can end this one. I hope this was useful. So I did not show the cloud API, but that's a very programmatic way of doing multi-agent system. This is a very simple cloud code, your partner, you would say, and how using that you can build a multi-agent system. That's what I showed. I hope this video was useful. If yes, please share this among your network so that others can also benefit. So yeah, I'll come up with some new topics. But yeah, thank you so much. Thanks for your time.